So, good morning, students. So this is just a video, a lecture, not a lecture video. This is just a video that you can refer for mechanisms that is regarding your project. Okay, and also this many mechanisms in this are mentioned in your syllabus. And okay, so I'll just go through each of them with some animation or real video. And you can once you get the project topic, you can check in net for more videos and more details, etc. Also you can ask me or Aggressor about the same. So the first one, this one is first one. This is called a beam engine mechanism. I think this is already mentioned. So this is earlierly used in steam engines and all. As you can see, it is a modification of 4-bar mechanism. You have a crank and it is connected to another bar, that is oscillating bar, which is fixed with a stand. Then it is the other side, we have, instead of a rocker, we are constrained the link motion to a straight line motion, straight motion, that is sliding motion. Okay, this is one mechanism. This may be given to you. Beam engine mechanism. This is another video of the same. Okay, that you can see. Then next one is, okay, this I will again show. Okay, so any more you don't know how to follow the same thing. You can do whatever. There should be a crank and there should be a slider, there should be a stand with an oscillating bar. These are the requirements. Then this is another mechanism which is called pantograph. So I will show one more better video is there, and later I will show it. Okay, this is not so fine, but you can see the use of this mechanism. What is the use? See, is copying it, right? So the actual use is we can copy images to on a larger scale using pantograph. So earlier it is used in for maps and all, in from a bigger map type to for a but copy and enlarge some given area. For that purpose they used. So this is simple, we can use for anything. You can copy any figure, etc. Then that is pantograph. I will show another one also. This is next one is Geneva wheel. Okay, and this you can see this is used for, wait one small. Now you see this is actually used for intermittent motion or discontinuous motion. You can see it's moved, then it is now stationary. Now again it is moved some distance, then it is again stationary. So what is the this is used for discontinuous motion. This is Geneva wheel, another important mechanism. You can think of the some products manufacturing that is in a line. For example, say bottle manufacturing, or you can imagine just for imagination. So if you, in that case, you can see bottle is required to be stationary to do some operation on that for a moment of time, then it have to move to the next stage. So similarly you can think of this. Okay, so it have to be stationary for some time, then it have to move again, it have to be stationary for some time. So this is a discontinuous motion, Geneva wheel. Another video. Okay, this is how a Geneva wheel you can create. Then next we will move to straight line mechanisms. This is Watt mechanism. You can see this path of this. This is called Watt mechanism or Watt linkage. I think you already mentioned it. And Watt linkage, the first few mechanisms we are discussing are approximate straight line mechanism. Why it is approximate? You can see this is not a straight line. This is a curve, the shape of it. So why it is a straight line? Because you can see from this point to this point, this is straight. Similarly, from here to here it is straight. So it can constrain the thing from here to here. The resulting will be somewhat on a straight line approximately. Okay, so that is a use. This is mainly used in what suspension and all in trucks and other what sports vehicles. This is what mechanism. This is simple construction. This is a 4-bar mechanism that links are connected opposite ends. You can see one fixed point is here, another fixed point is on the other side. Okay, you just compare it with the 4-bar mechanism, then you'll understand. Then we have two links and sorry, three moving links. So these two links that is connected to fixed point, this here is red and green, these two should be of the same length. Okay, in this figure particular this video, this is not look so, but you make sure that the condition is this red and green what links are say equal in length, and we can use a smaller link of any length to connect both of them, and the point where we can make this approximate straight line is the center point only. Okay, I'm sorry this video is not good, but you should just listen me. This is also not as the center supposed to be, but it is supposed to be the center to get the maximum what accurate straight line motion. Okay, that is what mechanism. You have a lot of videos and animations and explanations are available in net. Then we'll move to the next one. Now this is called a Chebyshev linkage. Okay, you see the motion. Once more you see, just listen. You can see the complete motion of this. Got it. So here this is also again approximate straight line. Here you can see from this end to this end, this will be an approximate straight line, and this is called Chebyshev linkage. Another one, see these straight line linkages straight mechanisms are used mainly for component to fit with the components where another the motion in other directions are not preferred. So that is to not deviate from the straight line. For example, sometimes it is vertical or horizontal in any directions. Okay, imagine a vertical one, for example piston. So piston cylinder arrangement, so the piston should go in exactly vertical direction only, should not deviate much from that direction. So for that purpose we can connect such a mechanism to piston, then it will be not deviate from the straight line motion. These are general applications of straight line mechanism, not only in piston. There are many such things. Okay, I'm just an example. Now this is what Chebyshev linkage. This is also available in net to refer, and all are available. Okay, then this here the conditions are condition for Chebyshev linkage are actually here we have a fixed link, right? This fixed link and the opposite link, the smaller link. So the fixed link and smaller link, the relation is smaller fixed link should be double than the smaller link. That is, if I am say this is L, small link is L, fixed link should be 2L. Okay, then other two links are of same length and this should be 2.5L. Clear? So this is 2L, these two are 2.5L, these rocking parts, then the other opposite link, smaller one is L. Okay, this is a condition for Chebyshev linkage. Also you can refer, and also otherwise you can ask me. Okay, Chebyshev linkage. Sorry. Then next we have what we call Roberts linkage. Okay, this is Chebyshev. Roberts mechanism. Here you can see the path. Again, we have a approximate straight line. Okay, this is another one, Roberts linkage or Roberts mechanism, straight line mechanism. Now here again we have condition is this vertical rod should supposed to be in the where center of this link. Okay, this should be fixed at the center of this link, and this red link 1, red link 2, and this one all should be of the no, sorry, I'll show another video. Wait. Okay, now in this position, if I am connecting from this point to this point, okay, imagine I am connecting from this point to this point and this point to this point. Okay, so you can form a triangle link. Okay, instead of this, then these line, what I asked you to assume now, these line and this line, and this line, both the lines and or both links and these two red links, all those four links are of same length. That is one condition. Okay, not about this one. So link 1, link 2, link 3, and link 4, all four are having same length. Then next is this link. Which one? Our fixed link and opposite link should be again such that fixed link is doubler than which one? Smaller link. Okay, these are the conditions for Robert's linkage. Now another, then we move to the exact straight line mechanism. The other three are approximate straight line. Now we have exact straight line mechanisms. So here we have what is called Peculiar mechanism. That is again in your syllabus, Peculiar mechanism. This is the mechanism. Here you will get not an approximate one. We will get the exact straight line and no other curves will be obtained. It will be an exactly straight line. Yes, advanced mechanism. And here you can see a number of links. The condition for this is these four links should form a rhombus. These four links, probably these four will be four will be equal. Otherwise, the opposite links will be equal. Okay, about that is the first condition. Then other condition: these yellow links are equal in length. Then this red link and blue link you can see is a fixed link. From this point to this point is blue link. This is a moving link. So this blue link and red link both are equal. These are the conditions for Peculiar mechanism. So this is an real actual mechanism. You can see that can move, this end can move only in a straight line. Okay, even without we don't want to constrain it, but it will move only when it is a free end. It will move only in that straight line only. Now this is another straight line mechanism. This is called heart mechanism. Okay, this is called heart mechanism. Please note. And here the conditions are actually again we have these two links are equal, green. Then again the two links are equal, and these are again. And heart mechanism, if whatever who are getting heart mechanism can contact me. I will give you more detail of this. So this is more but tougher than Peculiar mechanism that I will explain to you. This is heart mechanism. This is a second perfect straight line mechanism or exact straight line mechanism. So that was a heart mechanism. Then we have our familiar mechanisms again. We have 4-bar mechanism. We discussed all inversions of 4-bar mechanism. It's already shown things only, I hope. Yeah, I'm sure. This is a crank rocker mechanism. Okay, so no explanation required. If you have anything, you can refer your book. This is crank rocker. Then we have double rocker mechanism. Sorry, double crank mechanism. Here you can see all red and green, yellow both are rotating. The previous one only one is rotating, other is oscillating. Then we have double rocker mechanism. You can see none of them are rotating. So these are three mechanisms they may ask as may ask. Then we have reciprocating engine mechanism. This is another important one. So you see, this is in our automobiles and all. What you can see is this four-cylinder engine. We have four such. Uh, we have four cider crank mechanisms together, right? And so the single reciprocating engine mechanism. This is the basic one. We have cider crank mechanism, and also on single reciprocating engine. This one corresponds to a single reciprocating mechanism. We have a piston and inside a cylinder, connecting rod and crank. Okay, so this is another one. The next one is oscillating cylinder mechanism. This is again a inversion of what cider crank chain. So here the path of the slider is made oscillating and in form of a cylinder. So this is called oscillating cylinder mechanism. We have crank blue color, connecting rod green, then piston is inside it, and we have the oscillating part is a red cylinder. Okay. Then we have quick return mechanism. I see it. What is the use? We already mentioned that is in shaping tool or cutting tool. The one stroke is faster than other. That is the use of what quick return mechanism. Here you can see that one stroke is faster than other. This left one is faster than right one. Okay. Now we have elliptical trammel. Again another inversion that is already explained. You can see. So this may be asked to again. No explanation is required, I hope. Then next we have a Scotch yoke mechanism. Again, this is a inversion of double sided crank chain. Double sider means we have two siders. So the Scotch yoke mechanism, the change is crank is same. We have connecting rod and a slider, and it is moving in a fixed path. All are same. The only change is at the end of connecting rod. Instead of connecting the end to the crank directly, they are providing there a slot. So when the slot is provided, what actually happened is that turning pair between crank and connecting rod, we have a turning pair. That turning pair changed to a sliding pair. That means one turning pair reduced and one sliding pair introduced. Thereby it is a double sided crank chain inversion. So this is now a sliding pair. So as the crank moves, this will slide or slide. This will slide on this connecting rod end, and the connecting rod other part will move with the piston, which is constrained in this cylinder. Okay, this is Scotch yoke mechanism. This is also interesting mechanism. And this here he used a motor to connect to crank, to rotate crank. You can see the switch. So this is rotating with the motor, electric motor. You can also try this for all those you are getting any mechanism with a crank. You can use a motor. You can buy an electric motor that will be very cheap. You can buy a small motor and use a battery or something to rotate the crank. Okay, this is a double Scotch yoke mechanism. In both sides, the connecting rod we have only up this much in the previous case. Now the same thing is done on the other side also. So what we have, two siders or two piston and cylinder arrangement can be done in one single mechanism. This is double Scotch yoke mechanism. So next you have this is called a lazy tongue mechanism. So this is, here you can see again number of links are connected in a cross manner. Okay, this is used for terms are actually used for picking or holding picking some object from a distance. Okay, without touching it. So this is the same use to pick or pick a what object to a distance. You can use this mechanism, as here you can see with a single what sliding mechanism we are how can cover this much distance. Okay, that's called lacy tom. It's another interesting mechanism. Okay, so next is a hand pump. So I think I will cover in another next video. This is already more than 20 minutes, I hope. So I will cover it in the other video. Thank you.